The name of this lab is the Types of Chemical Reactions Lab. The purpose of this lab is to use different types of reactions to predict reaction products. For your hypothesis, we're going to put that in your data table, so we'll get to that in a minute. So here are the materials, and then when you turn the page, you're going to put in the first part of your procedure. And then on the next page, you'll put the second part of your procedure. So you can go ahead and put those on two separate pages. So now I want you to put your data table in. You're going to fold it in half so you can glue or tape it into one page of your lab notebook. That way, when we open it up, we can see the full data table. So when you open up your data table, you're going to see several columns. In the first column, you're going to see your type of reaction. The second has your reactants. The third column is where you're going to fill in your hypothesis, and you're going to write the formulas for the formulas for what you think the products will be based on that particular type of reaction. The rest of your data table is going to be used for your observations during the lab, and then the last column will be for your actual results, which I will give you at the end of this lab video. So in the first part of part one, we're going to be burning magnesium. So I have my strip of magnesium here. Now I'm going to put it on the watch glass, and then there will be a picture of what that product looks like. In the second part of part one, we're going to be burning a piece of copper. So here's my copper. Then I'm going to hold it in the flame. So as I'm looking at it, I can see that the copper is changing color, and I will put a picture of this right after this video clip so you can see what it looks like after it's been in the flame. So in part two, we are looking at sodium carbonate being heated in a test tube. So here's what it looks like to start with. And then we are going to heat it for about 2 minutes. You should be making observations about what's happening to the solid and what's happening inside of the test tube. So we're at about 1 minute. Okay, so I think we're at about 2 minutes, so I'm going to go ahead and do the wood splint test. So light my wood splint on fire. And there we go. In the first part of part 3, we are going to mix silver nitrate and a piece of solid copper. So here's our piece of solid copper. I'm going to put that in the test tube. Here's my silver nitrate. And now it's supposed to sit for 5 to 10 minutes. So I will include a couple of pictures that show the time lapse between now and when this reaction is finished. In the second part of part 3, we are going to cover zinc with hydrochloric acid. So here's what the zinc looks like. I'm going to put that in a test tube, and then I'm going to cover it with 3 molar hydrochloric acid. And here is what's happening in that reaction. In the first part of part 4, we're going to mix calcium chloride solution and silver nitrate solution. So here's my silver nitrate solution, and here is my calcium chloride solution. So they're both clear to begin with. I'm going to put my silver nitrate in my test tube. And then I'm going to add my calcium chloride solution. And so here's what that reaction looks like. Remember, those two liquids, those two solutions were clear to begin with. I can kind of see a solid forming on the bottom. If I were to let that sit, I will put a picture in after this video as to what this looks like after it sits for several minutes. In the second part of part 4, I'm going to mix my solid sodium carbonate, so that's what that looks like, that's the white powder in the test tube, with some 3 molar hydrochloric acid. So I'm going to add the acid to my test tube. And it got all fizzy. And I could hear it, I don't know if you can. And if I feel the bottom of that is very warm. So I saw it get fizzy, and the bottom's warm, and you could even hear it bubbling. In part 5, I'm going to look at the combustion of isopropyl alcohol. So I'm going to put 10 drops of isopropyl alcohol on my watch glass. And then I'm going to light it, and while it's burning, I'm going to hold a beaker up here so I can see if I can see water condense on the bottom of the beaker. So I see maybe a little bit of water condense on this side of the beaker. It gets just a little bit foggy. And so I see just a little bit of water over on this side of the beaker. So here are the accepted results for our different reactions. So for our first synthesis reaction between magnesium and oxygen, we get magnesium oxide as our product. For our second synthesis reaction between copper and oxygen, we get copper 2 oxide as our product. For our decomposition reaction of sodium bicarbonate, we get sodium carbonate, water, and carbon dioxide as our products. For our first single replacement reaction between silver nitrate and copper, we get silver and copper 2 nitrate as our 2 products. For our second single replacement reaction between zinc and hydrochloric acid, we get zinc chloride and hydrogen gas as our products. For our first double replacement reaction between silver nitrate and calcium chloride, we get silver chloride and calcium nitrate as our two products. For our second double replacement reaction between sodium carbonate and hydrochloric acid, we get sodium chloride, water, and carbon dioxide as our products. For our combustion reaction, we get carbon dioxide and water as our two products.